these are concepts that are pretty common, let's say, in general in the ICT environment, needs to be addressed in the aerospace industry quickly. And virtually manage performance of everything, both of the product and also the business, not only one time, because that's the second challenge, throughout life cycle. So change, that is, by the way, the engineer enemy in general, happens all the time. So we need to cover the full picture, the full life cycle of the product. Which is the vision for the engineers of this business future? Well, first of all, as we many times said, we need to simulate, to address the whole product needs to be validated. Validated means, of course, test. Test means real test or simulated. And through the whole product means that we have a product level, a subsystem level, or a component level. And again, the full behavior, the full physics that happen on this product have to be considered. And it's a system level approach. Instead, what we are moving, this slide is not casually an linear aeronautica one. They are applying exactly the V-model concept. So that's V-model is a typical system engineering concept, both in the first branch and in the second branch of the V. So in the definition phase for the requirement and specification, but also in the development phase for testing and validation. Simulation technologies are not just engineering oriented, because with the same concept, with the same algorithms, with the same technology that we use in engineering, we can also make a business intelligence application of it, engineering business intelligence, leveraging the huge amount of data, much more than in other areas of the company, for example in administration or in sales, that we are available in technical side. Again, both simulation data or real test data, a huge engineering business database that is somehow explaining how the product is working. And we need to gather, analyze, and present data to get to product business metrics and KPI, not only product, but also business. A business intelligence scalable information suitable to all organized level manager needed it. So from the CEO to the manager of the group of people working on something. And again, leveraging knowledge and history, so the past applied to the future. As I said, system engineering is an important milestone. First of all, because in aerospace and defense, this concept is pretty mature now. We just followed a few months ago the INCOSE conference where most of these concepts are being explained, also by many customers, many companies that are attending this conference. And again, product is simulated through virtual model aimed to create, validate, and optimize products, also in engineering business. So simulation technology is needed to create, test, control, optimize product development as a part of the ecosystem, of the PLM ecosystem. Ecosystem is a typical term that in system engineering is pretty well known now. Part of the PLM is also the simulation to validate performance functionality, but in terms of performance, what was called in the past virtual prototype is again a virtual prototype approach, but fully integrated into PLM or SLM. Let's say that PLM is the common term that is used, architecture, but also with a business model address to simulate, that is the only thing we can do in that field, through engineering business intelligence, leverage the amount of data, connecting the comparing model branches, and able to control product maturity and quality. So in terms of performance, I think that it's pretty clear what we need: the full product architecture, through a bill of material-like configuration, leveraging experience of PLM technology already done in morphology, geometry, also in manufacturing sometimes, to extend this capability of PLM also to performance, not only to geometry or to bill of material. And again, full performance behavior, that means a deep investigation in complex physics phenomena and a complex product, say, be able to make algorithms to simulate, to describe the physical phenomena, and to be able to solve these equations. This, of course, is something that we are working since many years. Integrated multidiscipline, different calculation models approach through on hidden mode, let's say, to the user. And also, at this point, with all this amount of data on the engineering side, to be able also to automate the optimization phase, working on those data, working on these equations in order to find the best solution. On the other side, on the engineering business intelligence, what we need is an engineering business model that requires again on data management of the data from engineers, from engineering, especially in terms of the testing and simulation area. And the very first thing is compared testing and simulation, something that we already are doing in many situations. They use an efficient ICT architecture for performance data. That is aimed, all this effort is aimed to efficiently support decisions that here are engineering-driven business decisions through simulation of data and through clever, effective data management analysis, showing a kind of dashboard style output that is very easy to understand at all the levels, from the engineer to the manager. So the directions is to simulate into full product, develop on system engineering-like mode, just summarizing what we said, navigate into it, into the model, into the result, into the specification data, that are arranged in a bill of material-like architecture into SLM, SDM coupled with PLM environment, in order to decide on business engineering matters using supporting tools to business intelligence technology and data. And again, reuse, capability to reuse, then store not only the data, but also the process we went to that data. And to be able to reuse, capture it from performance already tested and account into PLM, SLM database. So where simulation goes, especially in aerospace and defense today, technology maturity allows to extend the usage and the application to gain both in product and in business performance. And let's say that today modeling simulation is everything. I would say that this task is done somehow. Logistic manufacturing especially, let's say MRP, ERP, bill of material, PLM, 3D geometric modeling, etc. This is something done. What is work in progress is something different. Is first of all the capability to simulate the performance that is not only the geometry, is a little bit more physics, with different approach, and also the engineering business intelligence that we need in order to get those data into the ecosystem. Then typical scenario to cover for new simulation modeling products, asking or request is for blending technological key arguments, for example, instrumented, dashboarded, or integration, interconnected, integrated, intelligent, expert to reuse, and again easy to use. So in this environment, I think that instrument dashboarded is something that we already partially very well know. For example, capture. We are able to capture, for example, a phone business status on a part. We have to synthesize it for the engineering manager from the business purposes to a kind of KPI-like information that can be seen in a very synthetic way in order to allow, to facilitate, to take some decisions to the managers. Interconnected means, again, something we already started some years ago. Interconnected means, first of all, able to link to all other tools needed to accomplish the task, different usernames, different brands, etc. Again, a picture from Aeronautica projects we are doing that are showing pretty well why we need to integrate, for example, from an isolated operation to a value chain model. Through standard way to communicate, PLM, SLM, software application for engineering database, at all levels of the V model, CAD,